In this video, we are going to have a look at probability and replacement and how that has an effect on calculating our probabilities. So first of all, we need to understand, well, what is replacement when we're working with probability? So to explain this, we're going to have a look at two different examples. So we have two jars with lollies in them, so different coloured lollies. Now, the first example we're going to have a look at is randomly picking out a lolly, so closing your eyes, putting your hand in the jar and taking a lolly out, but then putting it back in. So for example, you might say, okay, I'll put my hand in the jar and I'll randomly pick out a lolly and I might take out a blue one. So now you can see that there's one less blue one. But when we have replacement, each time we put that same lolly back in, when we repeat the trial. So we might put our hand in the jar again, randomly choose a lolly, and this time it might be red. But we put it back in again, and then we repeat the trial over and over again. So with replacement, we always put the item back in, and the probabilities remain the same all the way through. So, for example, if you wanted to find, well, what's the probability that on my first attempt, it's a blue lolly? Well, the probability of blue would be 3 out of a total of 6, which simplifies to half. But then the second time around, no matter what, because I always put the item back in, it's still going to be 3 out of 6, or half. So the probability remains the same when we replace items, when we put them back in and then we do the trial again. Now, our second example is going to be without replacement. So that means that we don't put them back in. Let's run through an example. So I might close my eyes, put my hand in the jar, and then randomly pick a lolly out, and I might take out a blue lolly. Okay, so the probability for that first trial that I would draw out a blue lolly would be 3 out of 6, which simplifies to half. Great. Now, because I don't put it back in, the probability this time will be different. So I've eaten the lolly now, it's gone. Can't put it back in. I'm going to put my hand back into the jar again, and I'm going to close my eyes and randomly pick out a lolly. Now this time, because there's one less blue, the probability is going to be different. This time, the probability is 2 out of a total of 5. So there's only 2 blue lollies, one here and one here, and there are 5 in total. So we've had to adjust our probability for the second trial. So when we don't have replacement, when we don't put items back in, each trial is affected in terms of how we calculate the probability. So we can show these kinds of situations using tables as well. So this table is going to represent 2 steps to this experiment. The first step will be shown by these colours here, and the second step will be the one across the top. Now we're going to do this with replacement and we're going to do it without replacement. So let's whip through this one first. So let's say, for example, the probability that we draw a blue one first and then a blue one second. Well, because that's possible, because that can happen, let's write that in our table. Now this particular outcome, blue first and then red second, well, this can definitely happen. Blue first and then red second, and then you go and fill out the rest of the table to show all of the possible outcomes. So you can see that every single space in this table is filled out, and yes, you can see it's definitely possible to draw out a red lolly and then a red lolly again because you're putting it back in. This is with replacement. So you're putting that red lolly back in, and you possibly could draw it out a second time. Let's have a look this time without replacement. So this one's going to be slightly different. So the first outcome, what's the chance that you draw out a blue first and then eat it? Don't put it back in, and then draw out a blue again. Well, that's not possible because there's only one blue lolly, so you can't draw it out twice. So we're just going to put a line through this one. What about blue first and then red? Yep, that's definitely possible, blue and red. So let's write that in our table. Blue and then green, yes, that's possible. Blue and then green. And then we do the same for the rest of the table, making sure that for events that aren't possible, So for example, getting a blue and a blue the second time, even though you don't put it back in, that we don't fill that one in or we put a line through it. So you can see that our tables look a little bit different. So for these two different tables, the one with replacement, they're all possible. Without replacement, you can see that getting blue the first time and blue the second time can't happen. Or red the first time, red the second time. That one can't happen either, because if you take the red one out, eat it, and don't put it back in, you can't draw that red lolly out a second time around. So let's have a quick practice at using our table to find probabilities of different events. So our first little example is, what's the probability of drawing out a blue lolly and then a green lolly? So blue first and then green. So remembering this side of the table is the first step and this is the second step. So blue and then green is shown by this one here. And there's only one way that you can draw out a blue first and then a green. So that means that it's a 1 out of a total of 6. That's our probability of drawing a blue and then a green. Our next example is, what's the probability of drawing at least one of them being blue? Doesn't matter if it's first or second, at least one of them needs to be blue. So we have, so I'll do this in blue. That one has one blue. That one also has one blue. So does this one, and so does this one. So our probability is going to be 4 out of 6, and we can simplify that. We can halve both, so 2 out of 3. Great. Now, finally, what's the probability that when we draw both of our lollies out that none of them are blue? Okay, so how many of these outcomes show none of them being blue? Well, that has no blues. That one also has no blues. So it looks like 2 out of 6. And we can simplify that one to 1 out of 3.